Alice, Bob, and Eve explain Qudits.
I was tidying up today. I found a bunch of colored marbles that needed to go back into their tray. My sorting would be so much faster and neater if I could put these in more than just the red or blue bins.
That's actually a perfect analogy for Qudits in quantum computing.
Qudits are such an interesting extension of quantum computing. While most people focus on qubits, Qudits offer even more computational possibilities.
What's the difference between qubits and qudits?
A qubit can exist in a superposition of two states, typically labeled 0 and 1, like your red and blue marble bins. But a qudit can exist in a superposition of d different states, where d is any integer greater than 2.
Think as a qudit as allowing purple, green, yellow, and orange bins too, not just red and blue. A 3-state qudit is called a Qutrit, a 4-state one is a Ququat, and so on.
So they can hold more information?
Exactly. A single D-level Qudit can store the same information as log to the base of 2 D qubits. So one 8-level Qudit could encode the same information as 3 qubits.
But it's not just about storage efficiency. Qudits can enable more efficient quantum algorithms and potentially simplify certain quantum operations.
How would you physically create a qudit?
There are several approaches. You could use multiple energy levels in atoms or ions, different photon paths, or higher orbital angular momentum states of photons.
It's like how a spinning top can not only spin clockwise or counterclockwise, but can also have different angles of tilt and speeds, giving it many distinct states.
Are there advantages to using qudits over qubits?
Many. Qudits can potentially make quantum circuits more compact and efficient. Some algorithms might require fewer operations when implemented with qudits.
They also offer noise advantages in certain scenarios, since the states are further apart in the computational space. Some types of errors might be easier to detect and correct.
If qudits are so advantageous, why do we hear mostly about qubits?
Qubits are simpler to implement and control with current technology. Many of our best quantum control techniques were developed specifically for 2-level systems.
It's like how juggling 2 balls is much easier than juggling 5. As our technology advances, working with higher dimensional systems becomes more feasible.
So my desire to sort into multiple categories instead of just 2 is exactly what Qudits offer quantum computing.
Precisely. And researchers are increasingly exploring qudit-based quantum computing. There have been impressive demonstrations with photonic and superconducting systems.
In the quest for quantum advantage, Qudits might give us more computational power without necessarily needing more physical quantum systems, making better use of the resources we have.
So the future of quantum computing might be much more colorful than just the binary world of qubits.